both Alzheimer's disease and Parkinson's disease, we're making two types of progress. The first is we're understanding the underlying biology of the disease much more clearly. Now we have, for both diseases, a whole number of genes, and these genes are all related to each other in terms of their function. So it's really giving us clues as to the disease process. The other thing we're getting better at doing, though, is predicting who's going to get disease. And that's going to be very important, because the thing we're learning on the clinical side is to treat these diseases. We think we need to treat the disease really, actually probably before the clinical features become apparent. And so we're going to be needing the genetics to try and predict who's at high risk for these diseases, so we can initiate treatment.
So early intervention.
Early intervention is going to be absolutely key, I think. That's certainly the case for Alzheimer's disease. I think we know that for sure now. In Alzheimer's disease, what we're seeing is that the early onset forms of the disease are caused by the production of too many amyloid deposits. That's the initiating in the early onset forms of the disease. In the late onset forms of the disease, we can see it's the failure to remove those amyloid deposits which is turning out to be key. So it's a slightly different cause. In the early onset, it's too much being made. In late onset, it's a failure of removal and a damage response problem, I think. And I think we think that something similar is going on in Parkinson's disease. In many of the early onset forms of the disease, we seem to be making too much of these damaging proteins, but in the late onset forms of the disease, in general, I think we're going to find that it's a failure of protein clearance, which is critical.